We've been in this house for 22 years now. Our long-term goal was to decarbonize our home by eliminating greenhouse gas emissions, manage our loads better, and get to net zero. Our next big move was to switch our heating system from natural gas to an electric heat pump. Most contractors said I needed to upgrade my electrical panel before adding the heat pump, but I also heard that my 100 amp panel was good enough. I knew an upgrade, in my case, would be expensive, and the hassle, something I would prefer to avoid.
In Canada, there's a lot of incentives to go electric, but if everyone went electric all at once, that would put tremendous pressure on the grid. So we have to be smart about how we do it. If we don't right-size each house project along the way and transition efficiently, power utilities may not have the distribution capacity without costly system upgrades. We should only upgrade a home's electrical service if it's absolutely necessary, because upgrading has impacts on the overall grid.
We already replaced our gas stove with an induction cooktop. Many years ago, we got an electric water heater, and in 2020, we got an EV charger for the car. The 100 amp panel was enough for those upgrades, but adding the heat pump, I wasn't sure if that would be pushing it.
A lot of HVAC contractors and homeowners are surprised to hear that heat pump retrofits don't necessarily require a service upgrade, because that's contrary to what you hear. There's typically room on a 100 amp service for a moderately sized heat pump system, even allowing the safety factors required by the Canadian Electrical Code, especially if load control options that are allowed by code are adopted. But many contractors default to recommending an upgrade, which can run anywhere between $3,000 to $12,000. Rebates and incentive programs typically won't cover these costs, so it can be a major reason why people don't go ahead with a retrofit.
So when you're in this situation, you don't want to be guessing or paying for what you don't have to. It's important to figure out what you need.
You can complete a full analysis of the home's peak power demand with help from an electrical designer or an engineer. These days, power utilities have smart metering capabilities with easy access to this data. If you can't access this easily, you can get an electrician to monitor your usage to determine your peak load. The measured peak load of Gary's home was about 56 amps on his 100 amp service. With an 80 amp limit, we needed to figure out how much load would be added by his new heat pump.
First, we needed to make sure the heat pump was the right size. Our energy advisor told us our heat load was around 30,000 BTUs per hour. We selected a 2.5 ton cold climate heat pump that meets the full heating capacity of our home at design conditions when the outside temperature's at -8. Some contractors default to putting in electric resistance heaters that meet the full heating load of the home. This adds significant load to the panel capacity requirements and is probably overkill. You may opt for a smaller electric heater that's adequate to supplement the heat pump but minimizes the load on the panel.
Gary's 2.5 ton heat pump system has a maximum rated capacity of 34 amps, and it required a 40 amp breaker. We felt that was possibly doable on Gary's 100 amp service.
But here's the thing, we wanted to add more than just the heat pump. We were adding a greenhouse at the time and we wanted to heat it. And in the future, maybe we'll add some solar panels to the roof and a battery for storage to take advantage of the time of use rates.
With those additional future requirements, I recommended that Gary upgrade to a 200 amp service.
It was good news and bad news. The upgrade was going to be expensive, but we knew that we were making the right decision for our long-term vision for our house and for net zero energy. While we were at it, we worked with the electrical designer to implement a split panel solution, one panel for essential services and a mains panel for everything else. This gives us options to manage usage if we experience power outages or take advantage of time of use rates.
Whether or not a service upgrade is necessary, there are new technologies and smart panel tools that will enable sophisticated load management and long-term resiliency for your home.
My advice to anyone is to collaborate closely with the HVAC and electrical contractors. In my case, an upgrade to a 200 amp service was certainly justifiable. In many cases, it may not be. Thoughtful equipment selection, while following the electrical code, can reduce the need to upgrade the service, thereby reducing costs to the homeowner and the utility.